Hi, I'm Gordon Burkell for filmmakeru.com. At Filmmaker U, we create courses for film professionals to deepen and diversify your film skill set. Every week, we go live at 2 p.m. Today, we have a special at 12:30 p.m. We go live with film professionals to chat and give you a chance to join us and ask questions. Today, we're joined by Dado Valentic, who's a colorist, a color scientist, and should I also say, Dado, a inventor?
Well, maybe. I haven't been officially labeled as one yet, so hopefully maybe
So we get
it's
to break
definitely my
ground.
desire. Yeah.
So I get to be the first person.
Yeah,
Uh,
exactly.
well, I guess, do you want to talk about some of the technology that you've been working on and developing?
Okay, so first of all, thank you for having me. I think it's a great honor to be here. I have been following, by the way, your channel just before we start, and so I was actually positively surprised when you contacted me because you have one of the few good color training tutorials on your channel,
Oh, thank you.
because yeah, I have to, maybe before we start, I just really want to say that, it's how important it is that, this whole training has gone online now. I have been doing training as myself for years, as a classroom based, and now that we can't do the classrooms anymore, we really, we're wondering, how we're going to help industry move along, because, only through training we were able to actually get people, to be able to do the right jobs. And then after looking at all the kind of online options, it's just interesting to see how much online stuff there is for people who actually don't really are, like there is a lot of YouTubers who just look at the stuff like what we do and then just remake those videos, and they copy one another, and just this content seems to be same and boring and
Mhm.
all go and not really useful for any professional work. Yet you actually made an effort to really create an original content, bring a
Oh, thank you.
professional colorist, convince him. I would imagine it was a hard work to kind of say, hey, you should do this, right? Because no
Yeah.
colorist is really open to idea of sharing their ideas from the, first go. And you created actually a really good course. I mean, I
Oh, thank
haven't
you.
watched it myself. I saw like a few, those free episodes that you gave
Yeah.
it. And I thought like, this is just really, really useful. This is really what, you need to kind of know if you really want to do color grading
No,
professionally.
thank you so much.
Yeah. So no, I'm so happy to be part of this. So thank you as well. So let's go back to the question. What was it that you asked me again?
Well, I was asking, what is the technology that you've been developing and working on?
Oh, interesting. So basically, look, so you see, I have been colorist, for years, right? So I don't know, like maybe since 16 years, 17 that I've been doing it full time. But before I became a colorist, I was working first for Apple Computers as an engineer, and before that, I was working for Sony in R&D, and somehow I got a taste of development through that. I liked kind of, I learned what it takes to develop an application, software, hardware, whatever. So throughout my career when I was working, and I had a small boutique company in London called My Therapy. And the reason why it was called My Therapy is because people would usually come to me with things that they couldn't fix themselves. And they would then come and say, can you sort it? And that included very big facilities and big movies. Everybody, especially when the digital camera started, everybody was a little bit an unknown. And I became this person that would be able to deal with any digital material in best possible fashion. So in order for me to maintain that reputation, I had to invent, I had to constantly innovate and understand where the problems are, how could we fix them? And the solutions were not always there. I couldn't just go and buy a software. So we had to go sometimes and make our own thing. So for most of my career as a colorist, I always had a little kind of, research, part going in it in order just to keep us competitive. And that helped us to always be the first, like to do stereoscopic movies first, to do, whatever, technology. I was trying to stay on top of it.
Hmm.
And then in that process, I got contacted by an artist who's actually in New York called Jeff Koons. Not sure if you know about him.
Yeah.
He's like a big contemporary artist who wanted to make actually a VR piece where he wanted to create a virtual version of one of his sculptures. And that sculpture was supposed to come alive, and we needed to use some artificial intelligence in order to try to create a character because it was going to be like a game experience where you would be interacting with a sculpture. And we wanted to have an engine that would then learn the behavior of person coming in and so, direct it. And so because, of his reputation, we were able to, open the doors of research centers who were at that time very early on working on the first artificial intelligence models. And I got access to some of the very first developments in AI. And that completely changed my view on future, right? I was just, I actually remember a camera pointing on a screen that was playing black and white movie, and the AI was creating sound effects in real time. So there was an old black and white movie, with a train, with the engine coming into the station, and you could hear a sound effect of a train. And I was like, how is this possible that they can do this? And it was a Google at that time who basically, showed me the roadmap, and it just became clear that this technology is just going to become widely open. It's not going to be just a research as it was then. It is just going to be integrated, and we're going to be able to rent these kind of processing engines for our purposes. And they also already at that time have rolled it out to their photo application so that people could just type in the word and find what's in the photo. And I just went like, you know what, this is really what I think is coming, what's necessary, what they really want to do. And then I was at a position in life where a big studio was offering me to run, a big facility on their behalf. And I just felt that I didn't want to do this. At that time, I was running post-production company for already so many years. And I was like, I'm tired of this, servicing, especially now, the bigger the clients, the bigger the problems, the bigger requests. And I was like, I want to go and do the AI. So I sold the business, and I moved to California, to Los Angeles. And then I got accepted into an incubator program called Y Combinator, which is the same program that discovered.
Fantastic, yeah.
They told me it's harder to get in Y Combinator than into one of the Stanford University or something like that. It was the amount of people that want to get into it, but I got picked to do it, and basically that helped me to understand how to set a tech startup in Silicon Valley. I mean, I was always based in LA, but using that kind of methodology of VCs, investors, a great network of support. Google was the first company that helped and invested in company. Later came on NVIDIA, and we have kind of embarked on a journey that was now probably maybe 2 years. We're coming to 2 years of full-time research and development of this particular application, and just actually in 2 weeks' time, we're going to open this program to the public for the first time. So we actually have a software working in a very private select beta at the moment, but in about 2 weeks or so, we're opening it for the first time to a group of 200 colorists that we want to select and find, who will be able to help define the first AI color matching model. So what we're building effectively is a way that we want to assist colorists in accelerating their work and just being a little bit more precise in some of the work. And as you probably know, a job of colorist is can be described in 2 ways. So there is one way, which is the creative part, where we create a look. And that part is so instinctual that it's impossible to use machine learning or any other technology to really recreate that part, because that's the real artistic kind of side of our job. How we're going to influence viewers' mood and emotion by adjusting image in certain ways. So I never really even attempted to go down that road and try to automate that part. That's never really what we try to do. So we are leaving that creative look creation in hands of humans for now. But what then happens is, once you have created the look, and let's say you have a scene, and there is shots in that scene that were shot on different days, different camera stuff going on, it's a real kind of, job, and that takes sometimes longer than look development to actually match everything, balance it, and so on. And the problem we have is, you see, when I started, I would get maybe 4 weeks to do a movie, 90 minutes. Then the money got shorter. We had to get faster. Okay, 2 weeks is the maximum we would get. And then it came down to a week, or what it is now happening, because, all the productions now have moved to this kind of Netflix streaming model. And all we get is 4 days to grade 1 hour episode that has to be graded in HDR and SDR. And it has to look better than cinema in a way, if you know what I mean, because the competitiveness on a streaming market is so high. There is so much choice that viewers have. So that decision on color and how good something looks is incredibly important now, even more than ever, because, based on that look, people really identify if they want to watch show or not. So it's really become even more important for the look to be incredibly good. And our job became very difficult now, because we have these kind of crazy schedules where in 4 days we have to deliver an hour piece, which is just has to be immaculate in picture quality. Yet the time we have doesn't really allow us to do so, and we start cutting corners. And so we might decide, oh, I'm not going to track every window here because I don't have time to do that, or this face is okay. You have when you finish this hour show, you feel like, oh, I wish I had another day just to fix some things that I didn't manage to do. So my hope was that with this machine learning algorithm we developed, we're going to allow colorists to focus on those details by taking the part of automatic matching away from them, and just to say, look, just tell the machine what you want to do, what is the reference look, and machine will set your CDLs to you. And this is a very important thing. What we have a patent on is that our ability that we don't just match magically through movement of some sort of, algorithms that you don't understand. No, we match exactly how colorist works by adjusting the controls that colorist is using. And that's the main difference. What we do is we actually take the same controls that colorist uses and use that to match the look, so that if I'm not 100% happy with it, I just continue to where the machine algorithm stopped. And so just to give an example, on a very fast machine, it takes about 1.5 seconds to match a shot. Or on my laptop, it takes 8 to 9 seconds to match a shot. So for me to match an hour sequence, once I have put all the right looks and keyframes and scenes into it, it takes just, less than an hour, and I'm ready to roll. I'm ready to roll to do really cool stuff, the more important stuff, windows, secondaries, this, that, da, 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 da. So this is really what this whole kind of 2-year process was about. It was about, learning, of discovering first where AI can help us. That was also a thing, because you could do almost anything with it. The second thing was finding the best way how to do it. And this is I did many iterations with that. For example, the best way how I describe it is this, if you want to automate something, you still want to give user if we're going to build a self-driving vehicle, we won't remove a steering wheel from it. You understand? You still want to be able, put it on autopilot, but if I grab a steering wheel, I'm in control again. And this is exactly what we had to build with our matching algorithm. We didn't just want things to happen. We wanted colorists still to have the control to be able to, adjust image in the way how they did it. And it was a quite a process, you could imagine, to do that. But it feels great now to see the application working and to be just on the brink of really putting it out into the real world.
Now, before I ask the next question, I have a bunch of people who want to say hi. So Mark Todd Osborne says hi.
Oh my God.
Jason Bowdick from LA says hi. And Virgil Edward from, I think it says Philly, it says hi.
Oh, very good. Another moment. I actually, I was just trying to watch Mark on the other day. He did an interview. I really like him, and he was a guest at one of our colorist meetups. I'm a big fan of him. And Jason, I follow Jason's, he writes for Frame.io blog a lot, and he does amazing like write-ups on film, like emulation. I know, and they are friends, they come to the meetups. I love them. So thank you guys for tuning in. It's great to see you here.
So one of the questions, so you were saying it utilizes the tools. So that includes like, if it has to create a mat or something like that, it does it for you. So if it has to
Not at the moment. Funny enough, just before I came onto this call, I had, a briefing with our development team about the secondaries. We want really secondaries first. We have this planned, and we are working on it. But I really felt that, there is we need to give ourselves a little bit more time to just understand how best to integrate the secondaries into the pipeline. And also, like, I really wanted to focus right now on the launch of the product and not so much on the development. So I've decided to kind of just, say, okay, we're going to launch with a matching algorithm, which is really what we hope is going to speed up colorists and allow them to be creative again, instead of being technical matchers. And by the way, like, it's interesting, like just before the lockdown happened, I would have an assistant who would do this. My job, especially when I kind of started doing a lot of these Netflix shows, my job would be like this. I would go in and I would then make this look and set the look, and I would go. And other colorists would then come in and be able to match everything according to the reference. And I would and then even when I was just, doing the whole show, I would just grade the key shots in every scene. And then my assistant would go and match everything else. And that's how most colorists have started. This is really how we learned. I learned like that. A senior colorist would come to me and say to me, Dado, make it like this. And I do it. And then he would come back and say, no, it's not good. Do it again. And then that really made me better, right? And that's really how we trained, how all of us trained. But, I can't have a now assistant in where because I'm working from home. So I need a virtual assistant, I suppose. So my AI assist is actually going to become, this assistant, that I used in the past is going to be the machine. So I think it's going to be useful for that reason as well.
How does, and again, if I'm getting into the secret sauce, I understand if you can't answer this, but how does it work? Does it look at the scopes and everything and then determine between the images? Or
I love that question. I thank you so much for asking that question. Because this is how all color matching algorithms work at the moment. All they do is they measure the scope value, or what we call, code value, RGB value, right? But human vision does not work like that. That's the fact. We just kind of had to go and ask neuroscientists to really confirm this fact for us. We were just ignoring it, I suppose. We actually don't have a light meter in our head. Our brain doesn't care, what the code values are. And there is a lot of perceptual color sciences. And there is some fantastic research work, by the way, that it's out there. The only other company that I know that is taking full advantage of that is Colorfront. They have been really strongly, following their color scientists is on a cutting edge of that. And I have been studying this a lot, and especially there is a very good neuroscientist working in University of San Diego who helped me, get access to some of the very interesting research they've been doing that helped me understand and come to the conclusion that actually, to be honest, after more than a year of development, I had to pull the plug on everything we were doing and start again in the perceptual way. So we actually don't look at an image any longer with RGB values. We look at it in a way how humans would perceive an image, and we perceive it in a slightly different way. Our perception of an image is not exactly directly related to its RGB values. So we would look at the two images and we would find them that they match, but the RGB values would be completely different. And just trying to find that correlation was a really, really task that we had to do. So we had to develop a serious, so this is not one neural network that is able to do that, because neural networks are really stupid at the moment. If you want to put it like that, they're like a beginning of artificial intelligence, and they can do only one task. Like, for example, one neural network It's going to look through all of the frames in a shot and find those frames that are most suitable for best matching, for example, right? One neural network would analyze and say, I think this is a wide shot, this is close up, this is hand, this is face, this is this, this is that. Another would say and analyze, I think the lighting here is like this, is sunlight, it's white balance, like this, like that. So basically we have several of those kind of workers, neural networks that would analyze the image. And then based on that analysis, we would then assign the right matching approach. You understand? Because it's different if I'm matching close up to a wide shot than if I'm matching wide to wide, or if I'm, you know, like we see things completely differently, right? So that was a really, really challenging task. It was really, like I call this a learning machine to dream, you know, so don't give me the exact result. I don't want the exact pixel value. I want that dream kind of scenario to, and which is similar to how brain works. By the way, you know, what I did is, as a part of this research, I have submitted myself as a kind of, you know, test subject to this, you know, Center for Neuroscience, and they put a brain scanner on my head, and then I was color grading while they were scanning my brain. And it's interesting, you know, that what came out was that it seems that what happens when we are color grading, what happens, the way our mind works is that our imagination visualizes the result first. And that result, then we try to recreate by operating the controllers. Okay, so and this is happening in a milliseconds. You know, we look at an image, and then we have this kind of almost like a little moment where we visualize how we want this thing to be. It's not necessarily a conscious moment, but there is a particular activity in a part of our brain where scientists can say, this is the moment where you have been using your imagination. And that means, okay, I have drawn maybe from my visual memory, maybe from my, you know, part of my kind of, you know, wherever it came from, you know, we don't know exactly where imagination comes from, by the way. That's what they can't tell us. They can say that we have it, but not what inspires it. So they say, okay, this part of the brain, there's activity here. We know that this is associated with your creative, imaginative part. So what happens? So colorists would look at an image, visualize what it should look like, and then create it, okay? And you see, so this is this kind of moment of this visualization that happens really, which is kind of something that we were trying to understand. How can we create that reference look that our imagination creates? And it's not exact, of course. So that was an interesting thing. And another interesting fact, by the way, it's a little segue to the neuroscience, it's this: when we are color grading, okay, when I first started, of course, because it's all these machines, you know, so it's just very hard to relax and do your job normally, because you're strapped in these wires and they have to put like a particular fluid on your head, and it quite hurts, you know, these magnets, and this head is not, but, you know, so it took me a while to relax. But once I relaxed, I was in a state of alpha, constant alpha. And this is normally a state we achieve when we meditate. You know, it's actually, you know, like Buddhists, you know, like, you know, go and live on mountains to be in that state. And, you know, we as a colorist, when we really enjoy our work we're on and sequence we're working on, we become also in this little alpha mode. We're like a daydreaming, you know, what we're doing. And which kind of just really confirmed, you know, my belief that our job is more creative than technical, and that the tools we have at the moment are more technical than creative. And that, you know, hopefully, like, you know, with the evolution of the tools and simplifying them, we're going to be able to be more creative than technical by having tools that allow us to do that. It's just that we learn our tools so well that we stop thinking about them. You know, I can operate DaVinci Resolve with my eyes closed. I don't even have to look at the interface because, you know, my hands work, and that allows me to be in this alpha. The moment I focus on my screen and I look at the menu button, I'm back in the beta, because my brain needs to now concentrate and focus on certain items. So I'm certainly like on the long term trying to understand how we can assist colorists in a way that they can use more creative part of their brain instead of the logical part, because I believe that this is the purpose, our instinct that allows us to understand how an image should look needs to be coming from the creative source. So I believe it's not going to something happen next day or next year, but we're definitely direction at which we will be moving and how we want to develop color grading software in the future.
Now, so this is very interesting. How do you, because like, I guess there's a perception of AI that everyone always has, which is like robots taking over. But what I've been seeing in software is it's a lot of like, like you said, how do we make the tools work for us? So how do you teach AI to advance? Because it's not just a software that, you coded it and that's it. Like, how do you advance it? Or how do you teach it to advance, I guess?
How you advance it? Yeah, it's a good question. So the good news for AI is that there is like a large amount of open source research out there. Almost everything that is significant in AI is open source. What that means is that you can very quickly start with something that's going to give you a result pretty quickly. Okay, so that means that, the starting point happens relatively quickly. The moment you reach that kind of starting point, you realize that you're on a flat plateau because there is very little improvement because you're working with a model that's been trained only so far, right? So then what we do is we remove the last layer of training. So what happens is like, the neural network is built in such a way that it's basically trained up to a certain level and then, we're getting the results. So what we do is we remove that kind of top learning layer and we start building on top of it for very specific things that are happening at that moment. So what you do is you basically have to then go and say, okay, we have this model working, but it's failing on this type of shots. Okay, let's see how can we now improve those type of shots. And then you keep adding to that neural network, elements that will help you improve that particular thing. Okay, then when you have got it improved, then you go like, okay, great. What is going to be the next thing? The next thing, for example, our model at the moment has got a problem when we give them a reference that is blown out, when highlights are blown out. And our model doesn't know that it shouldn't look like that. We shouldn't have a look with the blown out highlights. We should try to protect them. So what it does, it tries to recreate blown out highlights out of every shot you're trying to match. So now we're having to tell it, okay, listen, you have to understand that when the highlights are blown out, that this is not what we want to introduce in all the other shots, and so on and so on and so on. So you basically literally on a case-by-case basis, you build it almost like a logic, that is not anymore so much, the core part of your neural network, but these are these little branches that help you, like fix some of these issues. And this is an ongoing process, which is the reason why we want to work with this select group of 200 colorists that will help us basically, find all those spotty points, that algorithms not very good at in order to help us to improve them. So actually almost these 200 people will be people who will define, the very first AI color matching algorithm. Their work is going to be what it will be reflected inside the algorithm. So, this is why I'm so excited about this process. It's going to leave our lab and it's going to get into the real world, different material. And then slowly we're going to start to integrate all of that experience and the works of all the 200 colorists we want to work with to create a refinement of that algorithm.
Yeah, before I ask my next question, we have Stig Olsen says hi from Oslo. Mark. Mark says more creative than technical. I love it. And Roberto says hi from Peru.
No, Roberto is in Puerto Rico. It's Puerto. Oh my God, he's one of the most talented people like I've ever actually seen. Roberto is an amazing guy. He's doing now a show. I don't think if I can talk about it, but I actually, he just sent me some of the stuff. It's amazing, like I love Roberto. He's one of my favorite people. And he's, by the way, had a chance to test the software already.
Ooh.
Roberto, it's okay. I said it to you. We didn't break the NDA. I have done it. So don't worry.
Well, so that brings me up. So you were saying that these 200 that you're bringing in are sort of teaching the software. Now, is there going to be some kind of, I guess, central server that constantly is updated once the software goes live, or is it?
Yes. So what we basically will be doing is we'll be collecting logs, and just also, with 200 people, basically what I decided to do is like this, we're going to, I have been running like for years, a training platform. I have this rule, like years ago, I went into like some spiritual teaching and there I learned that I should give 10% of everything I get back in order to be able to create that cycle of energy. And so I realized that, me actually teaching, being part of the education is going to be these 10%. So I really dedicate 10% of my time for the past X years to, giving people, back or, like learning. I am in a position to give somebody, not me take from it. It's a dead flow of energy. And we have a great platform there already. So I'm trying to now basically build like a program on using our Color.Training platform, where we actually are not going to focus on training of this algorithm. I want to focus on creative look creation, or like, on this kind of creative part, because I don't want people who are part of it to be influenced by the fact that we are using AI. That's not really what it's about. It's about how can we as a colorist become better in developing looks and creative, better looking material. That's the end goal. And that's what we want to focus on. Sure, we're going to use tools we never used before. And that's going to be a novelty factor in that. But I hope that novelty of AI is going to wear out quickly and we're going to focus on the real tasks. How can I make these images really, become what my imagination is trying to create? Mm-hmm. And so the program I'm trying to develop is almost like a look school, like we're calling it at the moment the look cook school, right? So where we basically are going to work for 1 month with a group of on development of looks, and we will deploy AI in it, but that's not what we should be concentrating on as such, because we want AI just to be a tool that we will use, and then we will help. We will then draw the log files from the machine and understanding, to what's happening, what's working, what's not working, and we will build that into the final release. So after we finish the course, it will take us several weeks before this becomes reflected in the code, and that's when the public release of the software is going to happen, like a few weeks after the end of this program.
So like if I get a copy, let's say, is my work going to also be added to it, or is it like, yes. So how do you prevent...
not just the work, but what we are doing is not the kind of actual images, but what we are measuring is what you're doing with your thinking. Exactly.
But how do you prevent, because there's been times where I'm like, oh, I got to teach myself a software, and I open it up and I just goof around in it for a bit and slowly start to learn it. Is there something that prevents, like a student just teaching themselves, or I guess lower quality work from being added to it?
Not sure if I understood the question. So tell me again. So just really want to repeat it. So there are particular softwares. I understand you said that they're very difficult to learn because you start and you kind of don't get there. Is this the problem? And then how would you help students not get into that kind of gap that they can't progress?
What I'm thinking is, so once it's released, it's still going to be updated by, people. No. Okay. So it's not going to be updated.
No. Once we release it, the model is done.
Okay.
Until we don't do maybe another, round of improvement on the model itself,
Okay.
I've actually have a person in mind that I would like to lead another round of development. It's one of the most legendary Hollywood color scientists that I would like to bring on after the initial release. But once the model is released, it's done. It's going to be working, but you have to understand, model is only mimicking what you do. Model is made to mimic to what you do. So it's not that it's always going to do what model thinks it's good. No, model is like it's this kind of it's a copy machine for your looks. Think about it like that. So whatever you created as your look, the model will try to recreate. And all we're doing now is we're trying to teach model to recognize what is significant in each look that needs to be recreated. Okay. And then we'll close the model. And then you go and work on it. And then we will then understand how to further improve it and what we do with it, and maybe in another point we release another model and another model that you can just be going to be able to add, you can inside your preferences can select what model you want to work with. And then based on your, type of material, you're going to be able to select different models that will give you the best and quickest results that you want based on what you're working on. Because, let's say Mark Todd Osborne just did this amazing documentary for Netflix, which is called Mucho, Mucho Amor, absolutely beautiful show. So the model he would have used for that show, but if he was to use AI, would have been completely different than a model he was going to use for a show called Act that he did last year, which was like a really like, a drama, quite kind of, eerie look and so on. So that wouldn't have been the same AI model he would have been able to use for those two shows. So this is really how we're seeing this model evolve, that we're going to just give particular types that will be better suited for different types of show and looks.
Oh, wow. And is this, were you able to use this with your work for Netflix that's coming up in the fall?
So we are actually working with the two major companies. And when I say major, I mean some of the biggest, companies in this field. I'm not able to say who they are, but they are basically at the moment integrating into their dailies pipeline. So in order to accelerate, the process of dailies grading, right? Now look, I just explain you what really is happening. Like a lot of work I do for shows like Netflix in particular are where I help post-production companies that are hired to do the job get to do the job in such a way that Netflix is happy with the result. They don't have to ever get a phone call from anybody, whether there's a problem or not. You understand? This is really the thing. And for many people, it's like difficult because, sometimes, because Netflix is expanding their production, and especially in Latin American territories at the moment, they have a huge expansion rate. They have to then work with facilities that never worked on a Netflix show before. So my job is to kind of sometimes go in and to say, okay, let's see how guys going to help you transform to what you do to, in a way, how it's going to work for you in the best way to deliver to Netflix, Amazon, HBO, whoever the client is, it doesn't matter. So what, it's happening is that, for example, like, when you have a crew like that, that's not quite trained, you don't get the consistently good results. Right. So dailies look one day like this, like that, and so on. So, and now for us who used to work like this for years, you wonder, why can't they get these dailies right? Why, what's happening? Well, it happens. It's the way how it works. Maybe, the IT was trying to color grade dailies on set with a different lighting scenario. I don't know. I mean, like, your things just, it's a crazy schedule sometimes, whatever happens. So what we try to do is try to bring more consistency with our AI model. So to say, look, you guys, just throw your reference shots at it and let it just do the job. And then preview it quickly before you render it out. And when you have, and usually all you have to do is just go click, 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 click through the shot, maybe adjust one or two a little bit quickly. So the process of daily suddenly becomes no problem anymore, right? It becomes, the reference is done by the DP, And the rest of the, because whatever, 2 hours of material a day doesn't really require genius to match, but it requires a lot of precision work. And that's where computers are good at, right?
Mhm.
So let the computer do this part. And we just go and check and make sure that it has actually followed the instructions that we have given it to it. So this is where we're going to see, Netflix shows adopt this technology, primarily for dailies at the moment.
I was gonna say that's like the perfect thing to adopt because it drives me nuts when dailies come in and
Totally.
aren't looking great.
Yeah, and you wonder, why and how and this and that, and and where about, it's and look, it's a first thing. I think it was a low hanging fruit for us to say, let us help you with that. So we'll see how this is then going to evolve and how things are going to progress from there.
Now I have someone saying hi from Ecuador. That's Julian.
Hey, no, Julian.
Yeah.
Yeah, very good. He sent me a photo of him yesterday with his little baby.
Wow.
I was like, oh my God, he was watching something, learning something, and then he had the baby. I know that feeling. I have also little ones, so it's like balancing between the two is quite an
It's very
interesting.
crazy. Yeah, at this point.
Exactly.
Now, and we have Anina Fa from Houston saying hi.
Okay, hi, hello.
We've got a lot of fans, I think.
I know I have been around for a few years, and so I suppose you get me. I'm happy. I'm happy that actually, I'm doing it outside of my own network as well. So this is just so great to do it. Thank you.
Now, I guess I guess what and I don't know if I'm asking this question correctly, but like, if I'm working on code, because I've done basic coding, like not the software, but basic, like here's PHP, here's Python. If I had an issue, I've got to start going through the code. How do you troubleshoot AI if it's self-learning and very adaptive?
That's a very, very interesting question. So okay, so I have to you have to understand this, that actually, while we are certainly using AI, we have a lot of processing in it, that it's not like a pure machine learning model. Okay. And so there is a kind of, most of the troubleshooting actually that we do is not to do with the model itself, because what we do is we kind of have, there are ways that help us understand what model is doing. There are pre-visualization tools that help us understand the weights inside an image and what model is focusing on, that kind of, so we can visually see what's happening and then hopefully adjust it and so on. So that part is kind of part of this kind of training. And you don't do this constantly. You train and then you leave the model and then maybe you come back to it again. So that's not really like how troubleshooting really happens. A lot of work is not like a pure model training. A lot of work is like a development process, really. Now, what we did was this, like a beginning of this year, I have met with an old friend of mine from New York called Mark Peterson, that many people know because he used to have Off Hollywood in New York. And he was a little bit between the jobs at that time. He just sold his company, this and that, and he saw what I was doing, and he really got excited and joined the company. And that was probably one of the best things that happened to us, because Mark is an incredibly, like, has a vision to, and understands what product needs to have, has years of experience, and also, like, is a driving force. So the first initiative we did was that we actually going to move away from this traditional development that we were doing in the cloud and move it onto desktop platform, because we understood that, my models initially were only working in the cloud simply because there was no processing any other way. So what we did is we moved it onto the desktop, and then we had to make a decision. Are we going to go PC or are we going to go Mac? And we made the right decision. It just turned out it was the right decision a few weeks ago after Apple announced the new ARM processors. What we did is we said, we're going to go Apple because it just because of that whole development world of Apple, even though it's super hard to find people who are really good at it, we just got lucky and found also people in New York that are top, Apple developers. And what we did is we have accelerated our models to run on Core ML, which is Apple's hardware accelerated version, 20 times faster than it was running in the cloud. And then what happens is this: Apple gives you the troubleshooting as a part of their development tools. They give you all the troubleshooting tools that you need. Mm-hmm. And then also what you do is you are like building a rocket. You put a lot of sensors inside your software that are basically creating a log. And that log then helps you understand what's happening and what's breaking. So we would have a situation, something doesn't work. So then we go through our logs and our sensors that help us understand where things have broken and then how to fix them. And I have to say that, Apple's development environment is just really well done for development work. We can attach debuggers to code running. We can, write logs. We can do this that really help us to kind of, sense where things are going wrong and how to basically fix them. I actually, when SpaceX was launching their last rocket, I was watching it live, totally excited about it. And there was one moment where they said that the main reason why they wanted to recycle the rockets, because they have this technology that the rocket doesn't just get thrown and destroyed, but actually lands. And the motivation behind it was not to save money, because very often they can't reuse that rocket anyway. No, it was to save the rocket so they can see what's happened to the rocket, so they can figure out where could be a problem that they need to fix before it breaks. They have increased their reliability by being able to rescue these rockets after the launch and looking, oh, look, there is a crack here. There is a problem with this part. There is a problem with this part. And, I feel that when we develop our software, we kind of do the same. We put sensors everywhere and we try to understand where is it breaking in order to be able to, contain these errors and make them work better.
Wow. Now, I have one last question that I like to ask people, and that's, what's your favorite guilty pleasure film to watch?
Oh my God. I like that question. This is like such a kind of, True Romance is definitely one I could watch.
It's a good one. It's a very good one.
I don't know why. It's just kind of, there is something in that movie that is just, has got, I don't know. I think probably I find myself in that movie a little bit. I have always liked that movie a lot. And then, and to be honest, what I really enjoy watching a lot is if I'm like, sometimes I just, need some, inspiration, is I like to watch documentaries, sometimes more than feature films, especially like, some, documentaries about some inspiring people, like people that are just, interesting. So like, the other day I saw a documentary about Quincy Jones, for example, and it just like, I like these human stories, and I like that. And this is really like, for me, like sometimes, just connecting, to like a human story for me is more important than anything else. That's what I'm looking for. But like, to come back to this kind of thing, is if there is one movie that I would be playing on a loop, or like that Desert Island Blu-ray disc, if there is such a thing, I don't know. It would be True Romance.
Fantastic. Sure. Well, thank you so much for letting us interview and chat with you. For those watching, next week we will have Jeffrey Wolf, who edited Billy Madison, Holes, and numerous other great comedy films of the 90s. Be sure to join us at 2 p.m. Eastern or 11 Pacific time next Friday. Thanks very much, Dado, and have a good weekend, guys.
Thank you, everybody. Thank you for having me. Thanks.
Bye.